So hello, am I audible? Am I audible? So hello, am I audible? So we would be working where we left off yesterday, and that was um, here, right? Um, and not we haven't done this syntax errors. We did, I guess we did these. No, we didn't do this. HTML becomes a method inside the new class. Okay, we are left from here. I'll just pop out the chat and see if let me know if anyone have any problem or anything that they want to ask. Am I the only concurrent watcher? I don't think so. Okay, so let's go, I guess. So we were at here, right? We did implement the check function. Check was calling inside this, and we have to do the advanced set and peak. Also comparison in previous we need to do. Okay, we implemented all these things, right? So basically what is that and it by the name signifies checks if the current token is EOF or not. Peak means is we peak the current token, not the next one but just the current one. As you can see from here, we peak the current one. I should put a comment here. Peak the current token. It may be, you may be confused by it, or I guess I am. By peaking means in queue or stack, right? What peak means is we peak the next element that we are on it. So in this context, peak is not the next one; it is the current current token. Current is the token where we are at now. Main struct used for parsing stuff. Okay, this should do. Now going on to the next one, checks if the return the token to pass, which returns the current token we have yet to consume, right? As I told you, and previous returns the most recently consumed token. This should be get self.current minus one, right? Previous one. The latter makes it easier to use match and then access the just match token. So what does this do? For check type, and check type is something here. This checks the current token, right? Okay, it is okayish. We can probably write a comment here. So I am a bit confused here, right? Um, if you're parsing this expression, right? So the assigning, oh, this is comparison operators. Sorry, that's just. Think I should. Okay, I should write this somewhere. So comparison equality, sorry, equality, this is the equality one. We are parsing the equality grammar, right? So for the equality one, just a second more, I need to think what was the precedence here. These are the associates, right? Associativity, whether it should be passed from left to right or right to left. Left means from left to right, right means from right to left. So double equals and not equals associates from left to right. This is somewhat different. The assigning one was right to not assigning one also is okay here. Okay, so this thing that I was looking for. For all these things, the mm, highest precedence is from primary to the expression level. So the lowest precedence is expression. I was looking for this only. I'll just write it down here. These things also. Okay, so Manav is here, right? Haha. So we so let's continue where we were right here. So the assigning of these not assigning but the associativity of these comparison operator is from left to right, I guess, right? Is from uh, yep, is from left. Then I guess we should make this somewhat clear. uh, okay, so this is from the from left to right. So if we do this, they should ideally flow from here to here, from left to the right. So this should be the first thing. I am just trying to see how this function is working. So if we go inside the comparison, this is equal. This is expression gives equality. Expression gives equality, and equality operators are double equals and not equals. So these so we need to do the comparison operator function here, and okay, I'll try to understand how this is working. Parsing. Let's just try to test here. Let's see what happens. I don't know what would happen, what would we should expect, but let's see. Tests, I guess. No, 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 not here. This should not be here. This should be inside a function. If in test, this is the equality one, right? Equality, and this should here be called test. And what we would do, we would provide a expr here, right? A new parser with token list and parser. Let parse parser equals parser new. Okay, we're also getting some tokens. Tokens, let token is tokens vec to vec token new here, right? So this would be a token. Why is okay, this is not in the scope. I should import it. Now this is okay, and we'll create a parser here, and then we'll call parser dot what would be the expression 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 function, and let's see, let this equals this. We should name this to let mute parser, and we should print this, right? xpr, we got it is. Now I need to do, what I need to do is to I am somewhat scanner here, scan tokens. This gives us the vector of tokens, right? We should what should we do, what should we do, what should we do? We are here in, oh sorry, in the here in this file, what we can do is comment all these things. Okay, this is not Rust or any programming language, so there is no support for double, I don't know what these are called, slashes. No. Now if we run this, okay, I need to provide with these, this a double equals b double equals c double equals d double equals e, right? Now we should see what all tokens are here. Okay, tokens identifier a equals b equals c equals d equals e, and then e of eof. So we should just copy them, and we should paste it inside inside the parser, and we can use this, and we can use this something like this. Okay, they should all be pub and pub struct. Okay, this should be string, right? Why are we using even strings here? We should be using stir, right? And we should import all the stuff, all the token types also. Okay, then here, okay, these all done, and we should use token type use create token type, and we can provide here identifier, then equal underscore equal, then identifier equal identifier equal identifier equal identifier, then eof. Ours would be eof. Now okay, this should contain the token list. Okay, and doesn't implement debug. So this is an expr, right? So expr does also implement the pretty print trait expr. Okay, pretty printer dot print. Okay, printer dot print ast printer. I think okay, for now let's just use this. ast printer. This should be accessed with a new function here. Then printer dot print expr, or not expr here, but res. Okay, let's test it. What would we be getting? Oh, not this, but cargo test. Okay, so this fails for some reason. Okay, this is not yet implemented. Parser.new, then expression. Comparison is not implemented here, right? So this should fail. Okay, this is expected. Oh, I didn't. Yeah. So we are calling firstly the comparison, then the previous token, the operator. This is the current operator, right? I guess this should be the current one. If match token would be here, then consuming the token here, right? This is why we are calling previous. Then comparison is also not implemented. Okay, this is the same function, not implemented anywhere. So we should be, next thing we should be doing is to implement the comparison operator here, the comparison function. Okay, 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 so this fails for some reason. Okay, this is not yet implemented. Okay, so this fails for, I'm not sure why, how is this working. If the person never encounters an equality operator, then it never enters the loop. In this case, the equality method comparison is that with the method equality. So it do parse. What I think is it should start parsing from the left. A double equals b. What I'm thinking right now, right? A double equals to b. This is comparison operator, comparison operator, comparison operator, comparison operator, comparison. Now in the next thing, the next loop, this should fail. Okay, okay, I am getting it now. Okay, okay. The parser falls out of the loop once it's a token that's not an equality operator. Finally returns the expression. Note that if the parser never encounters an equality operator, then it never enters into the loop. In that case, the equality method effectively calls and returns comparison. In that way, this method matches an equality operator or anything of higher precedence. Let's see. Okay, we need to implement this. This thing would be in a loop, right? Because it can be one or none or infinite times. Okay, then we should let res equals to term function. Okay, we are also calling this for operator term, and then we create a expression out of it. expr operator, right? Okay, this is factor and this cause unary, divide and star, unary, divide and star, dash and star, then return expr. These are all these are the simple things that I am guessing it is not that complicated. Okay, we'll implement these till the factor one, and we'll take some questions and just for a while, for like 2 to 3 or 5 minutes, then we'll continue. Okay, so let's just do in order from here, comparison one, right? So I'll try to implement it myself. So comparison is term, then some operators, then term. Let term expr equals to self dot term. We need to create this, and it is created. This should return an expr. Term should return an expr, right? The comparison also returning. Yep, the term would also return. While self dot match tokens, and here we would provide the tokens that we are looking to match. Token type, what sort of tokens we have here? In the comparison one, we are having greater equal, greater equal, then less and less equal, less token type, less equal, right? These all sorts of token we are matching. Now if we get the tokens, we should, if we match the tokens, we should get them by calling self dot previous, because in match tokens we advance the token to the right one. So after, when we call the previous, we get the token, we get the operator token, right? Then what we need to do is, we'll again call the term temp term equals self dot term. This should also be easy to understand. We are just following the rules here, right? And now we should update the expr with a new one that we got here. This should be term expr dot binary. Left should be the expr one, and the operator should be operator only, and right should be the temp underscore term, right? We just do this, and let's see. After doing all this, we shall just return the expr, updated expr here, and this should be inside a box. This is okay. Now this should be okay. All right, so let's see if okay. Oh, we need to have some mute also. Now it should compile. Cargo R, then okay, it compiles nicely, and the comparison all operator is also done. Now coming to the term one, right? Really great going. Okay, thank you, bro. I guess it's better to talk while doing something, rather than just doing and not talking about it. doesn't make sense, right? Also, if you have any questions, right, you can just ping them. I'll be happy to answer queries if anyone has. Okay, now coming to the term function. Term is factor minus plus factor star. So let expr underscore factor equals self dot factor. We have to implement this. We'll do this, and this should return an expr, and we'll just do this TODO. Also, after this, I think I'll be making some type of an OS. I did have a prototype for it. Actually, I was reading some person's articles that they have implemented an entire OS in Rust. So I'll be reading it. Actually, it would be that would be quite simple to do, because all the code is in Rust itself. The main thing would be the learnings that we would be getting, but yeah, in terms of, I guess, coding experience, it would be a lot less, because all the code is all in Rust beforehand only. Token type, then this is a term, right? Minus or plus, minus plus. Then firstly this should be mute. Now if we mask the token, we can firstly we can just return the expr factor here, and then if we mask the token, we get the operator operator equals self dot previous, because as you know, match tokens consume the current token, so we would get the operator from the previous token. Then we got the expr factor, an operator, and then we also need a new factor here, right? This one, let factor equals self dot factor. Oh, I guess I'm doing some. Okay, it is okay. Self dot factor. Okay, so it is right. Now we'll update the expr factor that we have. Expr factor equals to expr left would be expr underscore factor, right operator would be operator, and right would be the factor. We'll just format this and wrap it into a box. Okay, done. And same thing here also. Okay, done. A term expression, or term expr expression, a comparison expr, comparison expr, equality and equality expr, starting point. Expression expr. Okay, one thing I'm confused right now is why we are calling always the binary expr, not the unary or here. So where you're calling always the left operator right and left operator and right. And grouping is also something that we should look, or your literal or a unity one. I guess we would be looking at somewhere in the next thing that we do. Okay, it's coming out to be really great. I guess here also some sort of also some sort of written tests equal, but they are also test cases, right? But it is great. We can also like do this stuff. If we run, I guess this all should also fail because not implemented. I guess not yet implemented. Yep. This should be somewhere calling a factor function, which we need to do implement, right? A factor expr. Okay, let's see. We did the comparison one, we did the term one, and we are at the final one, final factor one. After this, we'll take a break. Let's just do this quickly. Let expr underscore factor equals, what is the rules of factor? What is the rules of factor? Factor is cell.unary. Cell.unary. We should also use and mute self, because we in the match one we would be mutating the our current object. Okay, so here, where were we? We were here only, right? We can just return this expr factor. We haven't expr unary. This should be expr unary, because we are calling the unary function, not the factor one. Okay, this is done. Then we call the cell.match tokens, and we provide the minus multiplication and division token, right? Token type slash token type not minus, but star would be star and slash, right? These were all the things. Then what would we call? Then we call the operator only. We were doing the factor one, right? We would call the unary, then unary only. Where were we? Here. Let operator equals self dot previous, then let unary equals self dot unary. Okay, this should be self dot unary only. It is fn unary. Okay, we haven't implemented fn unary. We should do it here only. Okay, then we'll mutate this and be like expr unary equals expr binary. Left would be expr unary, operator would be operator only, and right would be unary only. And we do box new this box new Shift F, we do this, and it is done. It is done. I guess we can compile it. This should compile. I guess we can also add some mm, error here, like if we don't give this the dash p, just take it from here, because every time we are calling dash p dash p. What if we uh, this panics because we are not hmm, giving the dash p option. The dash p is the path where the logs code is written, or else we would test it. Okay, there are two concurrent viewers. Let's see if you want to chat. I have 5 minutes till we get back. You can ask me any questions that you have in the meanwhile. And also tell me if you have any ideas for that I should do in future. I'll grab some water and we'll come back in a while. Okay, I'm back. Yep. So we are at. I guess there are no questions here, right? There's no one watching, so why would there be questions? Um, So we next we would be implementing the unary one. Unary, there should be a operator and a unary one. Recursively call, if we find a match operator, then call a unary, or this should be a primary. How should we? Oh, okay. This is easy. This is easy. Let's see here. Um, Unit is something like operator and a unary. While self dot match tokens and we would pass token type not. What are the token type names here? Bang or minus? Wait a minute, bang and minus token type minus. We get this right. This match is the first addition, and just as we were doing some other functions, we would get the operator as self dot previous, right? Then after this operator, we should call the unary function. Wait a second, there should be if, right? Why? Because this is happening for only one time, right? Why am I using while here? Okay. Then we can just return expr unary, and operator should be operator and right should be unary, and we should do this. And if this doesn't do, if there is no tokens here, we can just return self dot primary. This should be implemented here. Okay. This should be box. Oh, I am surprised that the compiler doesn't complains us when we are using recursion here, right? Or did we have used somewhere else also? Nope, this is the first time we are using expression recursion here. Okay, nice to know. Then the last is primary. Okay, so we are at the last thing that we need to implement, which is the primary expressions, right? So let's see how that would be done. We check if it's false, true, false, and nil. Okay. Oh. Then if match number or string, previous dot literal, number and string is literal, then the expression here consume right. Okay. There's still a long way to go, right? Okay, let's just not see the end. Let's just focus on the current one, right? What we are doing currently matters, not the not we not the things that we have to do. Actually, that also matters, but not now. Let's just focus on the now. This should be false. Token type. PR literal value should be false, I guess. Right. This is a string. Why are we using a string here? And the literal thing is okay. These must be objects here. Okay, we are using the string in case of these objects, so that's why we are using. Okay. Should be nil, right? I guess we shouldn't be using option, because if there is a nil that we get from the parser, we can just use a string to represent it, right? NIL, that would be a okay thing to do. Or else we can I'll just use a comment here. We can where was it? in the parser, here in the literal, this. Can we use string option here? Just remove this, remove this also, and then so now we need to do some modifications here also. I don't know where it is. Okay, in the test thing, the test one, literal should be none here. We provided none here, and here we provided. Just a second, I'll be back. Just a second. Or just let's see what actually I was studying some open source implementation of this, so I did find something here. Shout out to this guy, man. He has written some good code. I'm not parsing. Do we need to do this? No, I don't think so. In the in this one, we take a token dot new minus. We didn't provide anything here. Token type, token dot new. There's no literal here. Token dot new. Let's see. And the token dot rs. This is token type. This is token. And here this doesn't take any kind of literal. Okay, so what should we do here? I'll just remain the literal as it is here. We can do some sort of changes here only. In the literal we don't use none, but some nibble. I'm very excited to see what this would do when we run the code, right? That would be interesting to see. Okay, so this is fixed. I need to fix this also. Just comment this for a while. what else we need to do? Okay, we can just uncomment this and write to do here, call the to do macro here, right? So this suppresses the warning. We can just use nil dot toString here also, and in the scanner. Okay, okay. Literal is should be here. Should do this and add token string. Just remove this here from here and just put this here. Not this. This should be this only. This is okay. Then we'll do literal string, right? The second argument. We should just remove this some here. Cell dot substring. Okay. Okay. Okay, now all set. So what I think would do would be, other than the string and the numbers, everything would be having a literal type of nil. Yeah, this is we can check this only, right? This is okay. Now coming to where we were at the we were implementing the primary function here, right? Explain literal dot serve. Okay, then this should be nil dot toString. Then this should be cell dot expr literal. This should be mute. You can remove this. Okay, this is done. Next thing we would do is match the left parenthesis dot match tokens. Oh, match underscore tokens, and this should be token type left parent, and then expression would be there, right? Let expr equals to self dot expression, right? And operator would be self dot previous self dot x. Okay, why is there? Self dot expression, then self dot consume here. What is consume? Do we have any function here name consume? No. Consume, where it is later implemented, right? Consume, right? Self dot consume token type, right parenthesis, and then return the grouping, return expr of grouping. Then expression would be expr. We need to do this expr consume. This would give token. We need to panic here. This shouldn't have a parser, parser primary this current token would be self dot get tokens list dot get self dot current. Okay, SU size, and this should be like this, right? And where's this? Not valid. Oh, box. Now this should be valid. We need to implement the consume function now, right? We have, I guess, mostly implemented all the things. Then we are here at the syntax errors that we could be having while writing the parser. So I guess it deals with all the errors here. Let's see. Give a valid. Okay. There are two things that parser has to do. This is valid. Given a valid string token produce a syntax tree. This is done. On the other side, then this is not done. Which is given an invalid tokens, detect any errors until they spot the mistakes. So Rust is really great at this thing. If you have used Rust, the errors that are thrown by the compiler is really good. You can tell where's the exact problem is. So yeah, this is really important. Modern ideas and other words, it's constantly reparsing code often while the user is still editing it. And support like autocomplete. When the user doesn't realize the syntax is wrong, it's up to the parser to help them guide back onto the right path. The way it reports error is a large part of your language user's interface. Good syntax error handling is hard, but by definition the code isn't in the well-defined state. So there's no infallible way to know that the user meant to write. The parser can't read your mind and then report avoid crashing or hanging. Those are the table stakes if you want to get to the parser game at all, but you really want to raise the and beyond that, a decent parser should be fast and report any distance error there. Minimize cascaded errors. One single error, the parser no longer really knows what's going on. Okay, this is a really nice point. Yeah. Before it can get back to parsing, it needs to get its state and the sequence of forthcoming tokens aligned such that the next token does not match the rule being parsed. This is somewhat hard thing to do. So I guess what I can see here is, mm, what this is trying to say is, suppose if we encounter an error, right? So we need to set I guess current some rules in order for the parser to interpret the next sequential errors, not that. So it is part of a cascaded error thing, right? If the parser gets stuck into one error, then it can it cannot rephrase it to the next one. Rephrase, not I don't know what I'm saying. I guess it's unclear to me also. uh, we select some rule in the grammar that will mark the synchronization point. The parser fixes its passing state by jumping out of any nested production until you get back to that rule that is synchronizes. Then it synchronizes the token stream by discarding tokens until it reaches one that can appear at the point in the rule. Okay, oh, okay. This is this is somewhat a great thing, or this is explained. What I'm trying to, what I was trying to understand. This explains it. Additional real syntax errors hiding in those discarded tokens aren't reported, but also means that they are mistakenly cascaded errors that are side effects of the initial error responsibility data, which is a decent trade-off. Take yep. So place in the grammar to synchronizes between statements. We don't have those yet, so we won't actually synchronize in this chapter, but we will get a machinery in place for later. Entering panic mode. So I guess what we'll do is we'll try to write the right how to enter how entering into the panic mode situation. Let hmm, consume, right? Where was it? It was here. uh, if check token type, right. Okay, this shouldn't be right param here. This should be token type. Okay, in type, then if it is a token type, then I guess we should advance, we should consume this. Then if not, then we can panic what you were doing there only. We can just, oh, oops, my bad. So this doesn't pick up. I need to do some sort of error handling here. I'll just store this for later. We should use self.mute here, and then okay, this is done. Then this is the error, throw error peak message. Okay, this is interesting, but we should I guess I have to do this, and I really need to go. I'll do this in my, just a second. I'll take a note of it where we left, and I'll be completing this offline, this rest of the chapter offline, and I'll explain what I did in the next stream, I guess. Thank you for watching, guys. If you like this type of content, just like the stream and subscribe, and I'll be back later. See you.